With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
A non-homogeneous sphere of radius r has the following density variation. Okay, so this is the density variation, and the gravitational field at distance 2r from the center of the sphere is. So this is the density variation, and we are given three conditions. That means there are three different densities of material in a sphere. So let us try to draw the diagram here for this sphere. Let's say this is the innermost sphere, right? And this is the sphere with the density rho by 2, sphere outside this, right? And let's say this is the outermost sphere with the density rho by 8. Now the total radius of the homogeneous sphere is r. That means from the center, this distance, it will be r. So this is r, and the sphere with a density rho naught will be of radius r by 3. So this will be the innermost sphere. Okay, so this is r by 3 radius, and the density is rho naught. Okay, and similarly the density for rho naught by 2, right? The second sphere is, let's say this is for the second sphere, and its density is rho naught by 2, and the radius is 3r by 4, 3r by 4, and the radius of the outermost sphere will be r, but its density will be rho naught by 8. Okay, so here we have the distribution of our non-homogeneous sphere, and now we have to calculate the gravitation field, right, at a distance of 2r. Okay, so let's say that the distance from this will be, this distance is 2r, right? So at this point we have to find the gravitational field. So the formula for gravitational field at a distance r is given by g m upon r square. Okay, now in this case the r is 2r, so I can write Eg will be equal to gm upon 4r square, where the mass m is the total mass of this sphere. Now the problem is, in this case we have a non-homogeneous sphere with different densities. That means for every sphere the mass will be different. That means for rho naught density there will be some mass m1, and for rho naught by 2 density of sphere, its mass will be m2. Okay, and for rho naught by 8 density sphere, its mass will be m3, and sum of these three masses will be equal to the total mass of the non-homogeneous sphere that we have here. Okay, so therefore the equation for mass is m1 plus m2 plus m3, right? This is equation 1, and let's say this is equation 2. So to calculate the gravitational field, right, all we have to calculate is the total mass, this total mass, that is m1 plus m2 plus m3, right? Now let us see what m1 plus m2 plus m3 will be. m1, if I write, will be equal to, we know that the mass is density multiplied by volume, right? So for sphere 1 it will be equal to the density is rho naught multiplied by volume of a sphere is given by 4 by 3 pi r cube. That means 4 by 3 pi, and in this case radius is r by 3. That means r by 3 whole cube. So this will be equal to 4 by 3 pi r cube upon 27 into rho naught, right? This will be equal to m1, right? Let's say this is equation A. Now to calculate m2, that is equal to rho into v2, right? And in this case rho is rho naught by 2, right? rho naught by 2 into V2. Now to calculate V2, all we have to do is subtract the total volume of this blue sphere by the total volume of this green sphere. By doing so, we will have the exact volume of the sphere with the density rho naught by 2, right? So what we will have here is 4 by 3 pi 3r by 4 cube 3r by 4 cube minus r by 3 cube. So if I rewrite this, I will have m2 is equal to 4 by 3 pi 3r by 4 cube minus r by 3 cube into rho naught by 2. This is equal to 4 by 3 pi 3 cube is 27, right? Upon 4 cube multiplied by 2, right? 1 by 2, if I multiply it inside, I will get 128 minus 1 by 54, right? And I'm taking r cube common. So I will have r cube rho naught. So let's say this is equation B. Now with the similar method, I can calculate M3. For that, the radius will be r minus 3r by 4, right? So therefore, M3 will be equal to 4 by 3 pi r cube minus 3r by 4 whole cube into the density is rho naught by 8, right? For the outermost sphere, that will be rho naught by 8. So upon simplifying this, I will get 4 by 3 pi and taking r cube common and multiplying 1 by 8 inside the bracket, I will get 1 by 8 minus 27 upon 512 rho naught. So this is equation C for M3, right? So now we have M1, M2 and M3 and we can put these values in equation 1, right? So the total mass of the sphere, that will be equal to M is equal to M1 plus M2 plus M3. Also looking at equation A, B and C, 4 by 3 pi r cube and rho naught. All these terms can be taken out common, right? So in the bracket, what we will have is, it will be equal to 4 by 3 pi r cube rho naught whole bracket 1 by 27 plus 27 by 128 minus 1 by 54 plus 1 by 8 minus 27 by 512. So this will be equal to 4 by 3 pi r cube rho naught, and by solving this bracket I can take the LCM and simplify it. I will get 512 plus 2916 plus 256 plus 1728 minus 729 whole upon 13,824. So therefore I will have 4 by 3 pi r cube rho naught. The numerator will be equal to 4171 divided by 13824. Now upon multiplying this bracket by 4 by 3, so the total value will be 0.402 pi r cube rho naught. So this will be the total value m. Now from equation number 2, right, we have the gravitational field, that is gm upon 4r square. So we can substitute the value of m which we just calculated in this equation and get the result. that will be equal to Eg will be equal to G, M is 0.402 into pi r cube rho naught divided by 4r square. Okay, so this will be equal to r square will get cancelled, and 0.4 upon 4, it will be approximately 0.1 pi g r rho naught. So this is the value for gravitational field. So the correct option according to this will be option number A.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.